elementals. This is a carbon chain lengthening process that extends the monosaccharides by one carbon. The procedure is used for synthesis of rare sugar that are difficult to isolate, and is also historically important in determination of sugar structure. A key step in this reaction is formation of carbon-carbon bond by the nucleophilic addition of K-cyanide to the aldehyde, forming a cyanohydrine. Because of new stereocenter is formed, the lengthening of one aldose results in two enteric products. carboxylic acid spontaneously form a lactone, which can be then hydrolyzed with base. The separated diastomers are then placed in separate flasks to convert back to lactones with acid and reduced to aldehyde with NaHG amalgam. Reduced to D-lactose and D-modern method. Use a catalyst to reduce the nitrile to amine. So this is a process where changing CHO to CN on the top. Adding 应该是 adding CN to CHO carbon. Okay. So when it comes, it will form two. It gives added one more stereocenter. This one will be okay. So what we do, and these are the products. So what is the original one? So we added 2. It doesn't flip. So top is still the top. So the top is still the top. So these 2 are the 2 I need to focus on. So this one, another, and one another. Everything else stays the same. This one, these 2 are symmetrical to each other, and these 2 are symmetrical to each other. So these 2 were formed from the same, let's say, first one, and these 2 are formed from the second one. Can we tell? Or if we add do we need to know? Well, do we need to know? So this question, we are only thinking about which one are being added. So all we need to do is to look for the 5 sugar. So that will be But the bottoms are the same though, so it would be dx, right? The next 3 questions refer to the following information. So Killiani-Fisher extension of D gave rise to 2 alkyl helices. So this is pentose, this is 5, so 6. So it only happened once. So D, like souls, only went through the cycle once. Okay, and only at cycle once means only 1 extra carbon added. So we have, let's have this one here. So it's like so, CHO. We would have 1, 2, 3, and CH2OH, OH, H, OH, H. And only added 1, so it will be CHO, C2 CH2OH. Everything on the bottom stays the same, CHO, only the top changes, so it could be OH or OH. Everything on the bottom stays the same. Everything on the bottom stays the same. It doesn't matter. So we have 2 alkyl helices, X and Y. What is the stereochemical relationship between 2 aldoses, X and Y? They are mirror images. Because they are mirror images, you have S, you have R, they will be not identical compounds. Diastereomers, dia is a twin, enantiomers is only the top part is, where did I throw my eraser? Okay. So only the top part. So only the top part is different. So this is enantiomer. Anomers. What is anomers? Anomer. Only carbon with 2. A new stereocenter formed in the hemiacetal from the carbon, and this carbon is called anomer carbon with 2 anomer with 2 oxygen, 2 oxygens attached to a carbon. Enantiomers, 1 more stereocenter difference. Constitutional isomers, so they only have same formula. Diastereomers, mirror images, so they would be an enantiomer. But wouldn't the bottom stay the same though? Hold on. Did I remember something wrong? Might. Let's go back. Hold on. We're going back to this one. So for siblings. So when you have two, so this one, okay, 搞错了. So this one and that one 搞错了，所以说So diastereomers, they are at least one stereocenter. Differs at least one chirocenter. Enantiomers, this would be enantiomers. Okay, so it's this one. If I draw this one out, would it be easier? So I have SS, RR, RS, SR. So when they are crossing, they are I think I have this one saved somewhere. My list. Where's my list? Bookmarks. Untitled folder. Not here. How about here? Nothing. Where did I? Reading list. This one here. So I have RSS, RSSR. So when they're going in between, so they are diastereomers, and when they are going between their diastereomers, when they are going across, they are enantiomers. Something. Okay. Two aldo helixes XY treated separately with NABH. NABH4 do. 6-ring carbon. What did NABH4 do? Gives CHO to CH2OH. Is that what it is? But then if it is a ring, we would have because it's aldoses would have OH and H here. So I guess the ring will open. I guess the ring will open, right? And then this one gets oxygen, and this one gets, well, we might have something like that, an opened ring. Well, we would have something like this. So we would have a ring. We would have a ring, and then it will be opened up here. So it will be something like that. And then this one would be H2O, and this one would stay like that. 为什么我觉得是下边那个会不太记得嘞？And then we have this one leave, so we would have something like plus. And then with NABH4, 我怎么记得是那个 rotation？ 哎，不对呀，它是把这个加变成它呀。NABH4. Right. How did it happen? Esterification. This is already fat. I mean, yeah. We're still in the sugar section. What does sugar do? So reducing acetone with, and then we will have did we use a DH for somewhere else? Right. What happened? How did this happen? I didn't really go very detailed on this. But I remember this can go to that. Optically inactive. Optically inactive would mean that it's a methyl compound. So X is methyl. X and Y are traded. So two molecules are traded with this. X gave to a rise to X gave to a rise to a methyl compound. Why is this product optically inactive? B? I am not sure what happened. I don't know what happened. What is the process here? I might want to ask, what is the process here? I got it right, but what is the process here? Like, what did NADH do? Like the mechanism. I can probably put it down here. NADH4 sugar mechanism. So what does it do? So it reduces the double bond. Although hexose, when we are looking at a question with aldehexoses, does it mean that the 6-carbon sugar is a ring? Aldehexol, that does not tell you it's a ring. So it does not tell you it is a ring. But I got the top part right though. I got the top part right. So I got the top part right. This So the mechanism of Na, so it reduces aldehyde and ketone. So NABH4 aldehyde and ketone. So reduces aldehyde and ketone. Aldehyde and ketone. And they're here. Doesn't necessarily ring. Okay. What is the identity of the optically active product from the reaction with because it is a 6-carbon ring, so I have a 6-carbon sugar, and then give 2 products, 2XY, so 6-carbon treated separately. X gave rise to an so I can know that X gives a methyl, so gives a methyl, so X is它本身是so X equals galactose. But how do we Y? How do we know Y? Two aldehyde treated with NABH4. So so one more time. So we have 2 6-carbon treated with NABH4. It will have CHROH hat and CHROH tail. Okay. Okay. And then one of them is What is identity of optically active product from the reaction of Y? Okay. So, 为什么 What did I miss? What did I miss? Optically inactive. So it could have, but for glucose, we're not changing anything else. We're just getting it to that one there. What is the question 42? Is it connected? Next 3 questions. That's why. Okay. So it was from this one. So OH, H, and H is tellus. So is D. Okay. Got it. Hexos gave an optically inactive product, meso product. HNO3. So when we are meso product and treat with HNO3. This is the nitric acid. Nitric acid. Nitric acid is the one which gave 2 COOH head and COOH bottoms. Right? We have giving rise to the COOH only head, and we have giving to COOH head and tail, and we have only tail, and we have CH2OH head. Right. When the same oxals was treated with the reagent needed for Killian Filter synthase treated with CN. So we added one more carbon. Two monosaccharides were produced. One of this gave an optically inactive methyl. While the other gave is optically active product. What is the most likely identity of this? What does this one tell you though? We have a methyl product. We have so it gives it could be aldose or so it could be allose or galactose. Allose. Because it was one allose or one galactose, and if it changed both top and bottom, they both will be inactive. However, if we're treating both with adding one more carbon, allose add one more carbon, CHO. This one here could be OH or H. And then it wouldn't be so HOH, 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 HOH. 这个是 one of the products, and if we give another product, HOH, OH, so this will be methyl. And then if we have galactose, we would have CHOER 3, 4, 5, HOH, OH, OH, HOH, OHH, OHH, HOH, CH2OH, and then we would have something like CHO, OHH, HOH, HOH, OH, HOH, and CH2OH. And this one is no longer methyl, right? Both of them are optically active, so it must be allose. Okay. Which one of A to E is least likely to be involved in acid catalyzed hydrolysis? What does acid catalyzed hydrolysis do? Acid catalyzed hydrolysis, it changes changes H to OH, or does it add OH? What does acid catalyzed hydrolysis do? What does acid catalyzed hydrolysis do to sugar? Acid catalyzed hydrolysis. Treated with H2O and a strong acid. What does it do to monosaccharides? Nothing happens. Aldose can isomerize to ketose. Isomerization. So isomerization happens with acid catalyzed hydrolysis. It breaks glycosylic bond. It turns complex sugar rearrangement to another isomer. So acid catalyzed hydrolysis, it breaks glycosidic bonds turns complex sugar to simple sugars. How does it do it? So we're getting into breaking linked sugar to so we break it apart. Acid or enzyme, polysaccharide, glycogen. Did we actually go in and we did not. What is the mechanism of it though? Well, here. We had amine and we gave acid and water. It became same thing, but NH became O. How did it work? So we gave H plus, that one will attack. And then when it gets to and we gave this one H2. I would think when I gave this one, so it would be NH2, CH plus, and then it would be OH, H, CH2OH, and then another H comes along. And then OH come along. Maybe OH, OH. Attack. And then we will have CHNH3 plus and OH, and this one would leave. And when we have OH minus, and this would go, and then this would form a double bond. Okay, that's my theory. Least likely to be involved. So nothing changed, everything happened on top. Adding another I think this would happen, and this would happen, this would happen. after this is ejected, why would we have the H plus here? We would first, let's write it out like don't combine steps. We would have that ejaculated so that C, we would have plus and have OH, and then because this would have two bonds, this would go, so that would we would have COH, and then because we have this one here, but this one donate, I guess this would be the question, would this one donate the electron to stabilize this? Or another H somewhere? We don't have another H though. Anything negative in here? We have H2O. Morning. Hello. How are you?
you guys. Working hard. Just grinding. You are my saving grace. You are my savior. Literally. Oh my god. I asked her about like the terpene stuff.
I don't know, that just clicked for me.
I was like, wait a second. That like actually makes sense what you did. And then
This is like a maze. You just have to like avoid the oxygen.
and then I attempted it on like the sample like final, and I was like, oh, I did it. So I don't know if that's just a one-off, and like I guess, but like so sometimes you can like guess kind of like
kind of, yeah.
kind of.
The
Last
calorie.
night, I got home from where I was studying at the Global Shop, and I get home and I eat dinner, and then I make a coffee to study, and the power in my house goes out, and I'm literally, I was like, okay, I'm going
That's a
to bed.
sign.
Yeah,
That's a
so
sign.
I just went to bed. Yeah.
No, as you should. Like,
I guess it's not meant for tonight.
At least I think we're going to move on to nucleic acids today, and I think
Yeah.
better. I think just the last few weeks have been like 2 weeks.
Honestly,
Last 2 days.
lipids and carbs were brutal.
Lipids and carbs are brutal. Like, I have nothing to say about them. Nothing good to say.
Yeah, I'm hoping nucleic acids is good, and I feel like pharmaceuticals is basically going to be just memorization.
I think so. I think it's
I
just
might look at the slides.
Well, but at least it's fun. Something relating to real life.
Yeah,
at least
lipids is
cool.
so dumb. I'm not enjoying lipids.
What?
Except for the terpene stuff.
I think lipids is my least favorite.
I like the terpene stuff.
I know, you're trying to boss at it.
Yeah, I don't know. That was like, I was just saying, kind of like, how do I actually understand it?
You were like, I got it, and I was like, no.
Yeah, feels good to understand something for once because I feel like I never understand something. Especially just
Also,
for
it
the
helps
lecture.
to explain to someone else. Like,
Yeah.
I found out when I did understand a concept, like somebody asked me about it, I was like, oh, and I explained it, and I was like, oh,
That like really reaffirms it. Like
It really
you
reaffirms-
understood what was happening. I was so shocked. I was like, I was doing it the way like I remembered from class, and I was getting the right answers. I was like, okay, I think I understand. It gets like a coincidence when I'm getting it right multiple times in a row.
yeah, no,
So like, I was like, I think I get it.
super impressive.
Why did your molar math? Because I don't want it calculated.
Oh, for the next lab,
Yeah.
I thought,
I need the molar math for the chloro.
I don't want to do the lab.
It looks kind of fun. I'm not gonna lie. I just don't have time for it.
I got theoretical yield.
I haven't done it. I was just thinking the molar math. I can compare with you